Stacks and queues are two abstract data types. Let's take a look at how they operate. A stack is a collection of data elements that are stored in a linear method. A simple way to view this is as a vertical stack of blocks, like this. There are two main operations that are used to manipulate the data in the stack. These are push and pop. The push operation adds a data element to the stack. The pop operation removes a data element from the stack. A stack operates as a last-in, first-out structure. This means that the last item that is pushed to the stack when data is added is the first item that is popped from the stack when data is removed. When data is added to the stack, the push command is used along with the data element that needs to be added to the stack. When data is removed from the stack, the pop command is used. That will remove the last element of data added to the stack. OK, let's take a look at another stack. This stack currently stores the colours red, blue and yellow. Here is a set of commands for the stack. Pop, push green, push purple, push orange, pop, push pink. Let's follow the commands and see how they affect the stack. First, yellow is removed from the stack. Then green, purple and orange are added to the stack. Then orange is removed from the stack. Finally, pink is added to the stack. The size of a stack needs to be defined. This means that the maximum number of data elements in the lists needs to be defined. For example, the stack size of this stack is 5. If there are 5 data elements in the stack and the system tries to add another data element, a message is sent to report that the stack is full and the additional data cannot be added. If all the stack elements are popped from the stack and the system tries to remove another data element, a message is sent to report that the stack is empty and that there is no data to be removed. The bottom of the stack will always remain in the same place. It has a static position. The top of the stack, however, is dynamic and will move each time a data element is pushed to or popped from the stack. One common application for the use of stacks is backtracking. In the backtracking process, a system may need to remove the last actions that have taken place in order to get back to an earlier stage of the process. Therefore, a stack is easy to use in this situation as the items pushed to the stack can just be popped off it. OK, now we've reviewed stacks, let's take a look at queues. A queue is also a collection of data elements that are stored in a linear method. A simple way to view this is a horizontal line of blocks. A queue uses the same two main operations to manipulate data as a stack, push and pop. A queue operates as a first-in, first-out structure. This means that the first item that is pushed to the queue when data is added is the first item that is popped from the queue when data is removed. Let's look at an example. This queue currently stores the colours red, blue and yellow. Here is a set of commands for the queue. Pop, push green, push purple, push orange, pop, push pink. Let's follow the commands and see how they affect the queue. First, red is removed from the front of the queue. Then green, purple and orange are added to the end of the queue. Then blue is removed from the front of the queue. Finally, pink is added to the end of the queue. As with stacks, the size of the queue also needs to be defined. This queue has a size of 5. If there are 5 data elements in the queue and the system tries to add another data element, a message is sent to report that the queue is full and data cannot be added. If all the data elements are popped from the queue and the system tries to remove another data element, a message is sent to report that the queue is empty. Both the front and end of the queue are dynamic positions in a queue. This is because the front of the queue will move if data is popped from the queue, and the end of the queue will move if data is added to the end of the queue. One common application of a queue is a job list for a printer. Each time a computer sends a print job to the printer, it is placed in a queue. Each time the printer begins to print a job, it can be removed from the queue. An array can also be used to implement both a stack and a queue. Each element in the array stores a data element in the stack or queue. Why not try designing your own stacks and queues? Good luck!